Hello everybody, here's our little review of Olympus sz4045 microscope that is very suitable for kind of notebook repairing, or might be jewelry or something that doesn't require high resolution, but you need to have nice contrast and very flat field of view if you're talking about not expensive green microscopes. In our case, I've taken some stuff as a sample for checking field of view and resolution here. That is a metal ruler, that is M3 bolt, M3 with length of 6 millimeters, I guess bolt. An iPhone might be 7 or maybe 6, not S, motherboard, and as usual Apple's A13 processor. So we'll try now to see how this Olympus works with different auxiliary lenses. In base configuration with no lenses, its working distance is 11 centimeters. In our case, we have got some ring for attaching a light source, but we can unscrew it and you'll have 11 centimeters working distance here. And in base case, the distance between eyepiece and field of the microscope is 33 centimeter, or might be even a bit more, but not that significantly. This model has diopter correction dial only on the left eye tube. Right eye tube has no such option. That is not that good at all, to be frank. And the inclination of eye piece tubes is 45 degrees. That allows you to easily sit and still have nice pose even when you use auxiliary lenses that lift microscope from an object, increasing the field of view. So this 45 degree eyepiece inclination is very popular now, and most all modern green microscopes have such 45 degrees inclination. For our case, to have real field of view, I have attached to the left channel VHSZ 10X eyepieces with field of view 22 millimeters, and to the right eyepiece tube I have attached, not that easy seen, Olympus VHSZ 30 times eyepiece with field of view 7 millimeters. So left channel will let me show you real field of view, while right channel will let me show you real resolution. Okay, so to start I need to attach my fiber optic light here. So let me make a little pause to attach it. Okay, fiber light ring is attached to the nose of this microscope. So now let's try to see what is the field of view with base configuration with no auxiliary lenses. So let's just see it. I have to put ruler into the center part of field of view. So let's just measure our fields for different magnifications. So with the base eyepiece with the field number of 22, at lowest magnification our field of view looks like 33 millimeters, as it should be. When we make magnification, move magnification to the maximum position, our field of view goes to be, let me count, 2, 4, 6, 8, 10, kind of 11 millimeters. So if you are fixing something big, you won't get huge resolution here, but your field of view in base configuration would be acceptable, I guess. Okay, now let's move over the object we have to see how microscope shows us things. First thing we want to watch, to look at, is M3. Might be 5 millimeters bolt, and it's interesting for us to see how metal behaves with different light. You can see a chromatic aberration here, how it behaves, and you can see field of view. So here's our 30 times magnification, and you can try to see that we have obvious differentiation in the depth of view, even if 10x eyepieces. Okay, and you can see there are not that much chromatic aberration so far, but to be frank, we need to have our 30 times eyepiece to see real state of things. So let's do it. Okay, here's our 30 times eyepiece, and you might notice that we have a huge amount of violet color here. Let me take something. Wait a moment. Okay, so now we can see a real resolution as it's seen with our eye. So camera won't distract us now, and you can see the depth of field is definitely pretty shallow now, and you can see some false colors. It's pink, not pink, it's violet, and a bit of green. So technically, as it should, acceptable correction of those chromatic things. Okay, let's switch back to our 10 times eyepiece to move to other objects. Now let's walk for a while over the banknote. I have chosen this banknote because many people know how it should look like and how it looks. So let me just make proper focus here, and we can try to see real field of view here. And let's walk now over the surface of this banknote. What have we got in here? To be frank, the contrast of this microscope is pretty high, while sz51 and 61 have better contrast, but this one, sz4045, is still very well made microscope. So technically, if you're connected to jewelry or notebook things, it is just right thing for you to work with. But if you're connected to mobile phones, you'll feel lack of resolution here, and we are coming to some mobile phone parts now. So we'll see it. Okay, now we need to have maximum resolution again to see how these metal particles work. And by the way, you can easily notice that, let me check, might be I'm wrong with this. Let me check. So if I have a focus into the center part, okay, not that bad. With 10 XI pieces, let's look at things with our 30 time eyepiece here. And again, this metal ruler is very nice to see a structure of metal, because if you're connected to knife sharpening, the structure of metal is important for you, for evaluation how things work. Okay, so let's move a bit to this, don't know what have we gotten here. We have gotten very nice looking metal particles here. Okay, to be frank, I don't see much with those particles. Okay, so let's move now to some other stuff, connected with mobile phones. So I have gotten here a motherboard of iPhone, might be 7 or even 6, but I hope those parts which are used here are not much different on modern phones. So let's just look a bit at the surface. And again, I need to switch to other eyepiece to show you real resolution here. So let's look at it. Just some metal surface. Okay, let's move back to our 10x eyepiece. What else have we gotten? Here are the pins. I guess the processor was connected to them here. I don't see anything interesting with those pins, so I'm not going to have big resolution here. Okay, here's another place I used to show you previous microscopes. Let's look at it. I am talking about those two pins. I have shown them on other microscopes in my previous videos, so you just can compare how it's shown here, and to be frank, not that bad. Here's our real resolution. I wouldn't say it shows us much worse than those others. But to see stuff really, I need to look at, I guess, at some more complicated things like A13 processor. Okay. Let's look at those little parts just for your information. Smallest part. After that, that is middle size one. Oh, still small definitely, but a bit bigger. After that we can have this pretty big. Don't know what the part is that. So just say any part. And after that, let's move to this big thing. Don't know what is that at all, but we need to get there just to see those tiny structure parts. Okay, let's move over the board a bit farther. Here are those other parts I have shown you in my previous videos of Abbe, Olympus and Nikon. Don't know what is that, but it just have shown already. And I guess last thing we can see here would be, what would it be? I don't know, to be frank. Okay, so let's drop the motherboard, and now we need to go to our A13 processor. We'll see real resolution there, and we'll see field of view here. Let me make focus, get it back. And now we can walk over this processor to see stuff you already seen on previous videos. To see real stuff, I need to switch back to our 30 times eyepiece, so let me do it. And here are those parts you should be familiar with. Let's check focus here. I would say quality is at least nice. Don't know about resolution, because if I try to fix them I might get some complaints about resolution, but initially picture is very clean, neat, and I won't say that bad compared to Olympus SZX12 or Nikon SMG 1000. But let's see what else have we gotten here. Okay, let's move. So I'm trying to move you over places you already know, just to let you feeling of real resolution of this ordinary Olympus sz4045 microscope. I won't say resolution is that bad, technically it's acceptable, but for those who try to restore pins, I would say they wouldn't be happy with Olympus SZ4045. But let me finish surface, walking over surface. I guess you can recall those parts already, because I've moved here a lot with other microscopes. So we're just returning to our initial position, and now we're about to make our last move. Wait a moment. Okay. So technically, picture is pretty nice here. But what the move have we gotten here? I will say you. I have taken for you Olympus auxiliary lens with magnification 1.5x and working distance of 61 millimeters, and we will try to see how things work with real magnification. So let me set this lens on the microscope. Okay, so now I have attached my 1.5x auxiliary lens, and let's walk a bit over the processor, and we are going directly to 30 times eyepiece to see how things really work here. Technically we should have some chromatic aberration increased a little bit, but I won't say too much. Now let's walk over the same parts we have already worked on a processor and see how things go. So let's start with our initial position here. To be frank, resolution now is the same as Olympus SZX12 with its 72 millimeters objective. Not that bad, to be frank. Might be I'm wrong a bit about resolution, but at least it's close, not that far. At least it's 50% higher than it was initially without lenses. So let's walk a bit over surface. I don't say there is much of chromatic aberration now. Not much at all. The only thing you might be not that happy to is a bit inclination of fields left and right mutually, but it's not a big issue here. You have resolution. It is here. You should have recalled these parts I'm walking over. So let's just slowly see how things work here. Again, we are having lens, auxiliary lens 1.5x that gives us 50% in magnification and resolution and decreases working distance to 61 millimeter. To be frank, very nice picture here. Regarding its cost, that is pretty small. It's just nice option for you to have a huge leap in resolution. Okay, let me finish my walk, my stroll to our initial point. about here, somewhere there. So technically very nice option for you for restoring processor pins. Okay, we came to our original position. Very cool. Okay, and as last option I could show you 0.62x lens and 0.5x lens, just within a minute. Okay, so when I have attached 0.65x lens, Microscope has lifted 260 millimeters, and eyepieces have lifted to 39 centimeters from the focal plane. Now let's see a field of view. Technically we don't need to see resolution. We can try it, but we don't need. Now we're just trying to see field of view. So let's go to the... Okay, we can even see a bit of resolution for a while. So here's our field of view, and to see it clearly I need to give you a ruler. So our field of view turned to be 52 or something like that millimeters in minimum magnification, and I just can't count, let me see, and how many is it? 9 millimeters in maximum magnification. Again, in mini magnification we are having field of view of 52 millimeters or something like that, and we can just see how much of your motherboard can fit with this lens. You can see it. Also you can look at dollar as a sample for you of the field of view, and you can even see this little bolt. And let's get real resolution just for a while, just to see how things go. For real resolution, again I'm switching to 30x eyepiece, and we should have resolution 40% less than it was. And to be frank, when you attach auxiliary lenses, quality of your picture gets worse, as it should. It's sad but true. So technically we don't see any noticeable parts here at all. So I would say this lens could be used just as getting some big fields, nothing more. So don't need to switch to this resolution thing. We can just look at a field of view thing. And last lens I want to attach now is our 0.5 lens. So let's attach it. Last thing for us. Okay, I have finally attached 0.5x lens. Now we have tremendous 20 centimeters distance between lens and not much, not that much, something is wrong, let me check. Very funny, wait a moment. I have forgotten to replace lens, so technically I stayed with initial 180 millimeters working distance. Now is switched lens, so we have kind of 20 centimeters working distance, and distance between eyepieces and working plane is 44 centimeters, pretty high. Not sure everybody would work easily with such huge distance, but technically in some cases it might be interesting for you. So let's check just field of view. I guess resolution is not a question here. So here is our 1.5x lens, and field of view should be kind of 66 millimeters, but let me check. Yeah, looks like that. Yes, field of view gets to be 66 millimeters. Now let's see field of view with maximum magnification, and it goes to be, let me count, goes to be 13 or 14 millimeters, as it should. And having such a huge field of view, you can just walk over the place and see what size this field of view has. Pretty huge field of view. Definitely resolution is divided by 2, but in some cases it might be interesting for you to have such huge field of view in cost of getting resolution divided by 2. So it was our last. And just for fun, let's see real resolution on our processor. Our last attempt here, and here it is. Here it is. Let's move to our place we started with. It's somewhere here, and to be frank, I don't see anything as it should be. We are not about to fix pins with such lens. We just are about to do some other important things with such lens. So guys, thank you for watching. Thank you for those who was patient enough to look at stuff for such long time. And here it was our Olympus sz4045 microscope. Now it was lens 0.5x, and we have got a lot of stuff here to see magnified. Thank you for watching. Hope you will come to my channel again. Bye bye everybody.